Question 22 asks to write this in the form a root 2, where a is an integer. So the answer might be something like 5 root 2, okay, or something like that. So we've got an expression where we have surds in the denominator. And when you see this, you should be thinking to yourself, right, I'm going to need to rationalize the denominator, okay, to get rid of that surd. Also, what you need to be thinking is, because I'm adding and subtracting, I need to have like surds. So let me show you what I mean. If we think about algebra, if I'm doing 3a plus 2b, I can't simplify that, okay, because they're not the like terms. If I'm doing 3a plus 2b plus 7a, then I can simplify this bit because they're both got a in it. Okay, we've got 3 lots of a plus 7 lots of a, so I could write that as 10a plus 2b. Similarly, with surds, that same principle applies. So if I've got 5 lots of root 2 and I'm adding 3 lots of root 2, because they're the same term, I can just add them together. So 5 lots of something, add 3 lots of something, gives me 8 root 2. If I had 3 root 7, for instance, and I added 5 root 5, I can't just add them together, just like I can't add a's and b's together. So the first stage is we're going to simplify these and we're going to rationalize the denominators. So starting with 26 over root 2, to rationalize the denominator, you need to times it by the denominator over the denominator. Remember, if you're doing something divided by itself, that is effectively 1. Okay, so you're doing 26 over root 2 effectively by times it by 1, so the value won't change, even though the appearance will do. Okay, because we're going to get rid of that surds in the denominator. So multiplying fractions, top times top, 26 times root 2, that gives me 26 root 2. Some students say that it should be root 52, but that's wrong because we've got a number and a surd, and because they're two different objects, when we multiply them, they just get put together. So we get 26 root 2. The denominator is root 2 times root 2. Now, they are the same type of thing, they're both surds, so we can actually multiply them. So root 2 times root 2 is root 4, and the square root of 4 is 2. And this is a pattern that we should be familiar with. So if we're doing root 2 times root 2, it becomes 2. Just like root 7 times root 7 would make 7. So we haven't quite simplified this enough. If we look at the fraction, we're dividing by 2. Now we've got a number, so that number can be divided by 2 because it's an integer and that's an integer. So we can simplify these two, but like for the same reason from this, when we were doing this, we can't do root 2 times root 2 divided by 2 because they're different. Okay, but we can do that. So 26 divided by 2 is 13, so I get 13 root 2. Okay, like I said before, can't simplify that because that's a surd and that's a number. But this bit would simplify because they're both whole numbers. Next bit, 12 over root 18. I want to rationalize the denominator. So I multiply it by the denominator over the denominator. Like we just said, that doesn't change the value of it because root 18 divided by root 18 is 1. So you're effectively timesing it by 1. So top times top, put it together. Root 18 times root 18, 18. Now 12 and 18, although they won't go in exactly, both of them are divisible by 6. So 12 divided by 6 is 2. 18 divided by 6 is 3. And like we just said, we can't do anything with these because that's a root and that's a number. Now, that's not really what I want, because remember, because I'm going to be adding and subtracting in a minute, I want them all to be root 2. All right, I know it's going to be root 2 because it says it in the question. So I've got 13 root 2. I want this to be like 4 root 2 or something, so I can then go ahead and subtract them. So I need to simplify this a bit more. Now, root 18, any value bigger than 10, I would say, is quite a big surd. So you need to see if you can simplify it further. So root 18, you can write as root 9 times root 2. So if you think about your square numbers, 1, 4, 9, 16, and so on, all I've done is picked a square number that divides into 18, so that's 9. And I thought, right, 9 times 2 gives me 18. So I've rewritten root 18 as root 9 times root 2. Now the square root of 9 is 3. So simplifying that, I can write that as 3 root 2. So let's go back to this. 2 root 18 is actually 2 times, because it's next to each other, 3 root 2. And I'm dividing it by 3. Let's see how this works. 2 times 3, we've got whole numbers here, so that multiplies 6 root 2, and we're dividing by 3. This bit simplifies because I've got whole numbers. 6 divided by 3 is 2. This bit doesn't simplify. So that is now in the simplest form. Right, final bit, plus 2 root 50. This works similar to before. So 2 times root 50 means 2 times root 50. And if we think about our square numbers, if I just continue this list a bit more, you should be able to spot that 25 times 2 makes 50. So I can write this as 2 times root 25 times root 2. Remember, it's not going to be root 25 times 2. That's not going to work. They need to be both surds. Always write the square number first, because then we can cancel it down easily. So root 25 is 5. So I've got 2 times 5, lots of root 2. And like we've seen earlier, we've got numbers with times in them. So 2 times 5 is 10. So I get 10 root 2. So that simplifies to 10 root 2. So go back to the question. And we're now ready to apply our final answer. So we've got 26 over root 2, which was 13 root 2. We're then subtracting 12 over root 18, which we said was 2 root 2. And finally, we are adding 2 root 50, which is 10 root 2. And like we said towards the start of the video, now we've got the same like term, we can now just add them and subtract them. So I've got 13, take away 2, which gives me 11, add 10 gives me 21, so it's 21 root 2 is my final answer.